Okay, today we're going to talk about how to simplify radical expressions. Radical expressions basically represent the problems that deal with the square root symbol. So we've seen problems like this before. Like if I gave you the square root of a 9, you know the answer will be what? Just 3. The square root of 25 would be just 5, and so on and so forth. These are the numbers that we know. Square root of 100 is equal to 10, right? Because I'm asking myself, what two numbers multiply to get you this 9? What two numbers do you know multiply to get you a 9? It's 3 times 3, and that one pair of threes will come outside, and that will be the answer. Same thing with 25. What two numbers do you know multiply 25? 5 times 5, and then that's a pair that basically comes outside, and that's why you have a square root. 25 is equal to 5. Same thing with 10. What two numbers you know multiply 10? 10 times 10, and that is one pair, comes outside. That's usually how you simplify radical expressions. These are the ones that you already know. But what happens when I give you a problem that deals with something that is not as easy to simplify? For example, if I give you a problem that looks like this: square root of 80. There's no two numbers that are the same that multiply to 80. There's no 8 times 8 when I give you 80, 9 times 9 when I give you. So what you have to do is what's called a factor tree. And so how factor tree works. I look at this 80 and I ask myself, what two numbers do you know multiply to get you 80? For a second, forget about this square root symbol, okay? Forget about that square root symbol for a second. Just look at the 80. What two numbers do you know multiply to 80? There's many numbers, but on top of my head, I could just think of 8 times 10, right? And I go on further. What two numbers do I know multiply to give me 8? There's 4 times 2. And then I go even further. What two numbers multiply to get you 4? 2 times 2. And am I going to break down this 2? No, because what gives you 2? Just 2 times 1. And then you're back to square 1. You're not really going further than simplifying that radical, because 2 is a prime. So you stop at that 2. But then look at this 10. Can I break down 10? I think I can. I know 10 gives you what? 2 times 5? So I know that the factors, the prime factors of 80 are these numbers right here. The ends of my factor tree, which are called leaves, these 2's, and that 5. If I multiply all those numbers together, I would get 80. So this problem up here that became square root of 80, I could rewrite that as the square root of 2 times 2 times 2 times 2 times 5. And you try it, put in the calculator, you'll get 80. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 5 is 80. So that's square root of 80. But the same thing I did earlier about finding a pair of threes, for example, square root of 9. When I find my pair of threes, when you multiply those pair of threes together, you take 1 outside of the radical. For 25, when I found a pair of 5s, 2 5s, I took 1 5 out. So here, do you see a pairs? In the square root of 80, there's a pair of 2's here. So that means I'm going to take 1 2 out. I see another pair of 2's right here. So I'm going to take 1 other 2 out of the radical. And this 5, it does not have a pair, it stays inside the radical. So the simplified answer of square root of 80 is, let me see, I take 1 2 out, and I take another 2 out, so I'll multiply another 2, and the square root symbol, and what's left inside, just a 5. So on the outside I have 2 2's that are being multiplied, which gives you 4, and the 5 on the inside, you can't do anything about it, so it stays as that, square root of 5. And that is your answer to simplifying the square root of 80. Let's try another one. if I ask you to simplify the square root of 56, it's not a perfect square, and there's no two numbers that you know that multiply to get you 56. So here we're going to do the factor tree. Find my prime factors. So the first step is to decide which numbers multiply to get you 56. Well, let's think. If you look at your multiplication tables, which two numbers do you know when you multiply them get you 56? And if you can't think of any, look at that number that it ends with a 6, meaning it's an even number. So you can start doing dividing. You can start with the smallest number. I know that 2 will go in it for sure. I know 2 times a number will get you 56 because it's an even number. So I'll just do on the side some division. I'll divide. How many times can 2 go into 56? So 2 goes into 5 2 times. That gives me a subtract, get a 1, bring down the 6. 2 goes into 16 how many times? 8. So that means 2 times 28 gives you 56. So 2 times 28 gives you 56. Can I break down 2? I cannot. It's a prime number, so I'm done with that one. So 2 is done. But can I break down 28? What two numbers do you know multiply to get you 28? Well, I know 7 times 4 gives you 28. So let me write, let's see, 4 times 7. I know that gives me 28. What gives you 4? 2 times 2. What gives you 7? Just 7 times 1 is a prime number, so you cannot break that, so that's it. So that means the prime numbers that I have, another 2 here, another 2 here, another 7. So this square root of 56 can be written as the square root of 2 times 2 times 2 times 7. Okay, and if I want to simplify this, I'm looking for my pairs. What pairs do you see? I see a pair of 2 right here, so I'm taking 1 2 out, and this 2 does not have a pair, and this 7 does not have a pair, so I leave those two numbers inside the radical. So then what I'll have is, see, a 2 comes out, and then you have a radical, square root symbol, and what's left on this side? Just a 2 times a 7. Which if you multiply that, you get 14. So then your answer is going to be 2 square root of 14. And that's your answer. We could simplify radical expressions that are big numbers. For example, if I gave you to simplify this radical expression that's 245, you could do that by first doing what? Factor tree. What two numbers do you know multiply 245? Again, I have my calculator with me, and it's a big number, but it ends with a 5. So I know that 5 goes into it. I know 5 times that number will give me 245, so I'll do some side work. How many times can 5 go into 245? Let me divide. 5 goes into 24. How many times? At least, what? 4 times? So it'll give me 20. Subtract. It gives me a 4. Bring down the 5. So 5 times what gives you 45? That's a 9. That's 45, and that's okay. So 5 times 49 gives me 245. But 5 is a prime number, so I'm done with that. I can't break down 5 anymore. But can I break down 49? What two numbers do you know will give you 49? 7 times 7. So now I can't factor anything else because 7 is a prime and this 7 is a prime. So the square root of 245 is the same thing as saying the square root of 5 times 7 times 7. Next thing to do is to find a pair. And I see a pair of 7s in here, so that means 1 7 will go outside the radical. And so my simplified answer is 7 square root of what's left on the inside, just a 5. And that is my answer. Now let's do one more with variables inside. That might make it difficult, but it's not going to be. Let me show you. If I ask you to simplify this radical, the square root of 75 QR cubed. So I already taught you how to do the number, like 75, how to simplify that, but now I'm giving you variables. It's going to be the same procedure. But let me just attack one at a time. Let me focus on the 75, and let me break it down. What are the prime factors of 75? What number gives you 75? Well, 75, I know, what's like 3/4, so 3 times 25 cents, 325 will give me 75. And then 25, I know that's what, 5 times 5, and that's it. I can't break down anymore. 3 is a prime, 5 is a prime, 5 is a prime. I'm done with that. And then I look at my my q. How many q's do I have? I only have one q because it's to the first power. Remember, it's q to the first power, so all you have is just one q. So you can, that's its own prime right there. And r cubed, what would this one be? R to the third power, if you break that down, is what? That's just r times r times r. Those are the primes of r cubed, those individual ones, okay? So now that I know the prime numbers of square root of 75 qr cubed, it's going to be written this way. The square root of 75 qr cubed can be rewritten as the square root of, we have 3 times a 5 times a 5 times, there's 1 q, times there's r times r times r, 3 r's. Okay, same rules apply about how to simplify this. What you'll be looking for is pairs, a pair. Let's see, I don't see a pair of 3's, but I see one pair of 5's. This 1 5 is going to come out. Q's, there's no pair of Q's, but there are a pair of R's right here. So I'm going to take out one pair of R's and take it outside, and this last R will be left alone. So if I simplify it further, what's going to be my answer? So a 5 comes out, and then 1 R comes out, and then square root of what's left on the inside, a 3, a Q, and 1 R. And guess what? That is your answer. Okay? Hopefully nothing too complicated, and yeah, hopefully you guys like this.